All right, so we were discussing about relational algebra and specifically the costliest operator in relational algebra, which is very important, as well as the one operator which is cited to be the weakness of relational model, that is the join. So we have seen many variations of that: natural join, then theta join, EQ join. Then we have seen things like semi-join, a modification of the fundamental uh, join operator. Then also I have mentioned about variations of join like outer join, where you have left outer join, right outer join, full outer join, etc. Then we came to the concept of distributed databases. So there we have noticed the fact that distributed databases are fundamentally against the principles of centralized databases, whereas distributed databases talk about duplicating or replicating data. Centralized databases are basically on avoiding duplication or replication of data. So we will have a quick review of distributed databases where we will see the plus and minus side of distributed databases, and also we will see the architecture of DDBMS, Distributed Database Management System. Then we see the different levels of transparency, and we will see how do we compare distributed database management systems. So this we have seen the differences between LAN, WAN, and databases. And also we have seen that DDBMS using LAN provides much faster response time than using wide area network. So normally, if you deploy a distributed database system over a local area network, you will get faster response time. We were also mentioning
Excuse me, sir.
about, yes.
Sir, I have a little doubt in this one.
Yeah.
Uh, if like it's given distributed DBMS using LAN provides much faster response time. Sir, if we are performing distributed systems using LAN itself, why don't we just use centralized if we are using LAN only? What is the particular advantage that the distributed system will have, like use in terms of use? I'm asking why just we don't use centralize itself if we are talking about LAN?
Yeah, that is true actually. What you're saying is correct. In a local area network, which is probably spread across a single building or different floors of a building, etc., maybe the centralized database and distributed database may not make much difference. So on a bigger network with a distributed database option, you will really appreciate the savings on the communication cost. So you are right actually. So rather than LAN, if you have a bigger network, a wide area network, where the DDN, distributed database management system is deployed, you will feel the real benefits. All right. So the comparison between LAN and WAN, that is not that important for us. You know already. Uh, yeah. So there are two types of distributed database management systems where you have homogeneous DBMS and heterogeneous. So in homogeneous, you have the same database management system DBMS installed or deployed at every node of the local area network or the wide area network. Whereas in the heterogeneous version, you have different types of DBMS running on different nodes of the network. So each DBMS or each unit has got its own autonomy. All right. So the point here is that even if you are operating with separate DBMS at every node, the DDBMS can operate it as a single DBMS. Logically, you will get a feeling that the whole database is a single one, but you will be, I mean, actually you are dividing the database into, or you are physically they are separated. So a distributed database is logically interrelated collection of shared data and physically distributed over a computer network. Okay. So a distributed database, if you try to define, it is actually it is a collection of logically interrelated data which are distributed over a computer network. And a distributed DBMS, DDBMS, is the software system that permits the management of the distributed database and makes the distribution transparent to the users. So without intimating the users, or without the knowledge, or without telling which data is stored in which part of the network, the DDBMS software provides a transparent system by which the designer can distribute the data across the network. So the fundamental principle of DDBMS is the transparency. That is, the data distribution is transparent, or it is hidden away from the user. So the fact that fragments are stored or on different computers is actually hidden from the real usage. So I may not be knowing that the data that I have searched is coming from the Calicut branch, or I got the data from the Cochin branch of a particular node of a particular network that I may not be knowing. So DBMS has got the following characteristics. It is a collection of logically related shared data. Data is split into fragments and the fragments can be replicated. They may be replicated, and fragments or replica are actually allocated to sites, and the sites are actually connected by a communication network. So the data at each site is under the control of a DBMS. So data at every site or every individual site is under the control of a specific DBMS. DBMSs handle local applications autonomously. So when you are dealing with the local queries, the DBMS has the complete power. So each DBMS is autonomous, means when it is handling local queries or local applications, they function independently. Each DBMS participates in at least one global application. So the important difference between DDBMS and distributed processing is shown here. So you have different databases, or you have different fragments of the data, whereas in the case of distributed processing, so you have a centralized database which is accessed through a computer network from different nodes. That is often described as distributed processing. Whereas you can see that here you have three different replicas of the database. So you have three different copies of the database. So distributed processing of a centralized DBMS has got these characteristics. Actually speaking, distributed processing has a tight coupling when compared to DDBMS. All right, or DDBMS is a loosely coupled system, whereas distributed processing system is a tightly coupled system. So the database design is same as database design when it is coming to distributed processing. It is same as a standard DBMS. So no attempt to reflect organizational structure. So DDBMS, distributed database management systems, are tailored according to the organizational structure. So if you have a branch at Kochi, you will have probably a node there. Or if you have a Bangalore branch, you will have a node, some fragments of the data will be stored there. So some way DDBMS are actually reflecting the organizational structure, which is not coming in the case of distributed processing. So distributed processing on a with a centralized database is much simpler than DDBMS. I mean, DDBMS is slightly complex or complicated than centralized or distributed processing systems. And distributed processing are also more secure, or security wise also centralized databases are more secure or better than DDBMS. But only issue here is that in distributed processing you don't get the advantage of local autonomy. Here again there is an illustration. So you have another version called parallel architecture, where you have shared memory and shared disk model, and you have a shared nothing model. Okay, while comparing here is a comparison between DDBMS and centralized database. Or we can say the plus and minus sides of DDBMS. So just go through the different bullets. Anaka? Anaka
Hello,
is
sir.
there? Yeah.
Hello, sir.
Anaka, can you say, can you just tell how economics advantage of a DDBMS? Can you explain this particular aspect, economics, data economics? Can you explain why this advantage, or what do you mean by economics here? Anaka?
Sir, I don't know.
Okay. Adhar? Adhar?
Yes, sir. Sir, when we use the distributed database, so the scalability is higher. Like if we want 10 times the current capacity or current speed, then we can speed up 10 different machines and in the DDBMS. But getting a 10 times more powerful machine can be exponentially expensive or even infeasible.
Okay, Adhar, it is not clear. Avinash? Avinash Kumar?
Yeah, yes, sir. Sir, I think that since in distributed database management, the databases are kept at different locations, so the amount of storage that needs to be used is less. But in case of in other case, the database management system, the data stored at one place. So due to that, the data storage required is more.
No, but data storage is I mean, but the total data that you have to store is the same, isn't it? So you have data about, let us say, Indian Railway has to store the data about, say, 1 lakh trains, or 1 lakh trains, train services.
Yeah, but due to
There
that,
you have,
whenever we are using the, whenever we are querying, then due to that, we need to apply less joins. That is why the processor needed is less, means it will be less.
okay. So can anybody say open to all? What do you mean by economics, better economics?
Sir, is it related to data availability? Because if we have data available in just centralized space against data available in distributed space, more people can interact with the data distributed space, and hence probably that might be the effect for economics.
Yeah, that is already coming as a different, another point here. Improved
okay.
availability. I'm just asking about economics. Vishal,
Sir, or sir, related to backup or recovery,
backup or?
recovery and backup.
Okay, so what actually it means is that the cost will be less. Cost or money, we are actually talking about the communication cost. So communication is costlier nowadays, and also it is going to take more time. So when somebody is trying to answer a query, and if he can answer it from the local hard disk, it will be much faster than getting it from a remote hard disk. So the cost of getting some data remotely through the communication lines is going to be more. All right.
Sir, is the economics on the advantage side and the cost on the disadvantage side, are they both different?
Economics on the
Like I see economics on the advantage side and there is a cost on the disadvantage side.
cost on the disadvantage side. Yeah, actually here actually it talks about what do you call savings on, or the better economics on reducing the communication cost. So what is the cost on the disadvantage side? Can anyone say?
Setup of the entire structure itself. It requires more hardware structures to at least to be set up.
Yeah, not only that, you are going to copy the data, isn't it, on multiple places. So definitely
Yes,
the investment or the cost of hard disk will be more, or the you want to
peripherals.
yeah, you need more disk space at different places. So it is going to be costlier.
Yes, sir.
Okay. All right. So on the advantage side, it reflects the organization structure, improves the shareability and local autonomy, improves availability because you have multiple copies of the data available. Even if one copy or one node fails, you can get it from another place. So reliability is also more, and you have improved performance because you get faster responses, or maybe the throughput can be more number of transactions or more number of queries can be answered over a given period of time. And modular growth means, can anyone say modular growth? What does it mean? Vishal? Vishal Sona?
Yes, sir. Some
Yeah.
modular, sir.
Can you say what you mean by this Modular growth.
So I don't have any idea.
Louder, please, Kishore.
So I don't know these answers.
Okay. Chetana.
Sir, as it is distributed means we can, it is scalable means we can add more sites and
Okay. You can add as and when there is a requirement. For example, currently there is no node or there is no network at, let us say, Mumbai, or there is no node, or I mean, at Indore, there is no node. Now, suddenly there comes a unit or there comes a center at Indore. So you add a network and you copy all the required data to the Indore server. So in this way, you can go on more in a modular fashion. You can add more nodes and expand the network. Similarly, if a particular node is down or particular node is getting cancelled or removed, that can also be done with minimum disturbance to the rest of the network. That is actually called the modular nature, right? So security, integrity control is more difficult. All right. So that is actually a disadvantage for this. Security is also an issue, and lack of standards, lack of experience. Database design is going to be more complex. These are some of the disadvantages of the distributed database management system. So why integrity control is more difficult, Demira?
Yes, sir, I'm audible. Hello.
Why is it difficult? Yes.
I believe like because the data is distributed and every particular node has its own control on the data because of heterogeneity, maybe it becomes more difficult to control that.
Okay, you may not be having the same integrity constraint everywhere. So because every node is autonomous, it can have its own constraints. So that can probably affect the integrity of the system as a whole. And lack of standards, again, it will be difficult to implement a common standard across all the nodes. And lack of experience is another disadvantage. And database designs for distributed databases are going to be more complex than designs for centralized databases. So these are the disadvantages of DDBMS. And on the left side, you find the advantages also. So homogeneous and heterogeneous, and if every node or every DBMS, if everything is going to be the same, we call it as a homogeneous DDBMS. Or if nodes are different, the DBMSs are different, we call it as a heterogeneous distributed database management system. Okay, homogeneous means all sites use same DBMS product. Maybe everyone will be using MySQL, or everyone will be using PostgreSQL, or everyone will be using Microsoft Access, like that. So it is going to be much easier to design and manage. Approach provides, this homogeneous approach provides incremental growth, and also it allows increased performance. Whereas heterogeneous sites can run different DBMS product underlying data models. So sites implemented by their own databases. I mean, in the case of heterogeneous databases, the sites are implemented on their own databases. You will have Oracle at one site, and you will have probably PostgreSQL at another site, and you will have Microsoft Access in a different one. So it goes like that. So the translation story is required to allow for different hardware, so different DBMS products and different hardware and DBMS products. So this may allow different DBMS, different hardware, and different hardware as well as DBMS product. So typical solution is to use gateways. Gateways are used to take care of the these heterogeneity issues. All right. Now, open database access and interoperability. So just read the slide. So when you go for an open database, so there will be a common SQL API, and there will be a common database protocol, and there will be a common network protocol. So the common SQL API will allow client applications to be written that do not need to know vendor of DBMS that they are accessing. So you will be provided with function calls or APIs. So you need to only provide the necessary inputs, and you will get certain expected or standard outputs. So you need not bother about which DBMS you are using, etc. But you will access the database through the APIs, SQL APIs. So here you will have a common database protocol which enables DBMS from one vendor to communicate directly to the DBMS another vendor without a need for a gateway, and also you will have a common network protocol. So these are the important characteristics of an open database model. All right, so multi-database system. It is a DBMS where each site maintains complete autonomy. So, it means resides transparently on top of existing database and file systems. It presents a single database to the users, but actually they are physically separated. It allows users to access and share the data without requiring physical database integration. So that is the advantage of going for MDBMS. It allows users to access and share data without requiring physical database integration. So you have federated MDBMS and unfederated MDBMS. In the case of federated MDBMS, it will look like DDBMS for a global usage and centralized database for local usage. It will have both the features. It will look like a DDBMS for global usage, and it will act like a centralized DBMS for local usage. And for unfederated means it has no local usage. So these are the major functions, things to be supported in a DDBMS. Please go through this. Okay, so these are the functions of DDBMS.
Sir,
Yes.
Sir, I had a doubt that extended concurrency control, sir. Can you give one example?
Extended concurrency control means?
So I'm not getting any picture about what is about.
Yeah,
So
we are
what is
we are going to see that in detail because you have different copies of the data. I mean, in the case of centralized database, you have only one copy of the data, and even if there are many users concurrently accessing the data, there is no harm. You may probably lock the data and then use, or you may put a read lock and use, or you can have some concurrency control mechanism. It is easy when you have a single copy of the data, but when you have multiple copies of the data, as we have seen in the last class, I mean last semester, in the distributed computing class, when you have multiple copies of the data, then the normal concurrency control protocol will not work. So you have 10 copies of the data. So when you are locking, probably you have to lock all the 10 copies. Or you may lock majority copies, 6 copies. So like that, the concurrency protocols are to be extended when it is coming to DDBMS. Is that clear?
Yes, sir. Yes, sir.
Okay. Okay. So DDBMS is actually providing two views. First of all, it acts as a globally it acts as a single logical database, whereas physically it will act as separate separate database system. So let us go for how we can allocate the data. So 4 alternative strategies are adopted for placement of the data in a network. So just go through those 4 different options. In a DDBMS, you can allocate data in these one of these or more than one of these 4 ways. So you can have a centralized allocation, that is a single database and DBMS stored at one site with users distributed across the network. You can have a partitioned allocation where the database is partitioned into disjoint fragments and each fragment is assigned to one site. Then complete replication where a complete copy of the database is copied to every site, and selective replication where combination of partition and partitioning, replication and centralization are used. All right. So in normally you will be going with a selective replication. So some data which is very popular will be replicated. Some data which is not relevant beyond a particular node will not be copied, or it will be stored only at that point. Like all right. So here comes a comparison of these whatever we have studied till now. So this is very important. So please go through this comparative table. This is an important slide. So we have seen 4 different strategies for data allocation, that is centralized, fragmented. Then you have complete replication, selective replication. So they are compared based on 5 parameters: locality of reference, reliability and availability. Third parameter is the performance. fourth parameter is on the storage cost, and you can also evaluate them based on the communication cost. Just go through the table. Here you have a high level comparison of different schemes for data allocation. Centralized, fragmented, complete replication, and selective replication options are compared on 5 different aspects. So you can see that locality of reference is lowest for centralized. Also the reliability and availability are also the lowest, and performance is not satisfactory, and storage, but the storage costs are minimum, and communication costs are going to be the highest. So the first option is not recommended in general. Okay, so the selective replication is considered to be better among the 4 options, where you have high locality of reference and you have high reliability and availability, satisfactory performance, and average storage costs are average, and also you have low communication cost. Of course, this comparative table is valid only if the database design is good. So fragmentation, as you know, applications work with the views rather than the entire relations. So the efficiency means data stored close to where most frequently used. You will be storing data to nodes which are very close to the place where it is widely used, and data not needed by local applications are not stored. Security, and so not available to unauthorized users. You can have local security policies, and parallelism can be supported with fragments as a unit of distribution. A transaction T can be divided into several subqueries that operate on fragments. All right. Okay. So the correctness of fragmentation, there are 3 correctness aspects for fragmentation or correctness as fragmentation rules. There is a completeness rule, reconstruction rule, and disjointness rule. Just go through that. Please go through the points. The three correctness rules: completeness rule, reconstruction rule, and disjointness rule.
Sir,
Yes.
sir, what I couldn't understand the exception vertical fragments. So how this
Exception?
is vertical fragments, sir. So
If data item DI appears in fragment RJI, then should not appear in any other fragments. That means that is actually the disjointness property. So if a data item appears in a fragment RJI, then it should not appear in any other fragment. So this is exempted for vertical fragments. So when you are taking vertical fragments, you require at least one common column when you are taking the join. So such columns are allowed to be replicated. So if you are fragmenting vertically, the columns or individual subtables are joined using our join operator or the natural join operator. So unless you have at least one column common, you will not be able to join them together. So there is a need for replication of at least one column. So the disjointness property is not applied to vertical fragmentation. Is it clear?
yes, sir.
Yeah. All right. So more about horizontal fragmentation. So as you know, here the each horizontal fragments contains a subset of the tuples of the relation, and it is normally defined using the selection operator. So you will be selecting few tuples which are satisfying a criteria or a predicate T. So it is all about finding a minimal set of predicates. So set of predicates is complete if and only if any two tuples in same fragment are referenced with same probability by any application, and predicate is relevant if there is at least one application that accesses the fragments differently. So similarly, you have vertical fragments where you apply the projection operation and get the subtables. All right. So vertical is a subset of attributes of a relation. So it is determined by establishing affinity of one attribute to another. As I was telling, as a student from the student table, you will be having your attributes related to the hostel stored in the hostel server, your food habits, or you have any allergy, or you have vegetarian or non-vegetarian, or you are staying in a single room, double room, or you are in an AC room. All those things will be stored in the hostel server. Maybe the number of courses in which you got test grade, number of courses where you had an A grade or your CGPA, SGPA, all those things will be on a different server. So it is determined by establishing affinity of one attribute to another. And you can have a combination of vertical and horizontal, which is actually called mixed fragmentation. And derived fragmentation means horizontal fragment that is based on horizontal fragmentation of a parent relation. This ensures fragments frequently joined together or at the same time, at the same site, and it is defined during the semi-join operation. So in the case of derived fragmentation, you will ensure that fragments which are frequently joined are stored at the same node of the network or at the same site. If relation is small and not updated frequently, it may be better not to fragment the relation. Small relations, if you fragment, it may not give you any advantage as such. So the basic objective of DDBMS is to provide transparency. Okay, so this overall objective is to give, equivalence to user of a DBMS centralized database is actually full transparency, not universally accepted as an object anyway. So you have 4 types of transparency: distribution transparency, transaction transparency, performance transparency, and DBMS transparency. So the distribution transparency means people should not know from which fragment you are actually accessing the data. Just go through the slide carefully. Okay, so it is self-explanatory. It makes many things transparent to the user. So naming transparency is also there. Each item in a DDBMS must have a unique name. Okay, so that is difficult to achieve. So the solution is to create a central name server. Loss of some local autonomy. Central site may become a bottleneck, low availability, and it may affect the performance of the network. But every data item should have a unique name, so that can be implemented by means of a central name server. Then transactional transparency, please read what is it exactly. Okay, one transaction can be divided into multiple sub-transactions, and the DBMS will ensure that ensure the indivisibility of both the global transaction and each of the sub-transactions. Okay, so transaction transparency ensures that all distributed transactions maintain distributed databases, integrity, and consistency. Then transaction transparency, you can just see further, it is actually concurrency transparency, and it also talks about failure transparency. Okay, so concurrency, concurrency transparency means all transactions must execute independently and be logically consistent with the results obtained if transactions are executed in some serial order. So this particular criterion is actually described as serializability, and we will study serializability in detail in one of the coming classes. So concurrent execution of a set of transactions will be considered correct only if its end result in the database is same as that of some serial execution. Okay. So even if some failure occurs, that should be transparent to the user. All right. So performance transparency. So no performance degradation due to distributed architecture. So it determines most cost-effective strategy to execute a particular request. So you have DQP, distributed query processor, which maps data requests into ordered sequences of operations on local databases. And it must consider fragmentation, replication, and allocation schemas. So these are the CJ dates rules for DDBMS. Fundamental principle is to the user, distributed system should look exactly like a centralized system, and it should provide local autonomy, and it should not depend on a central site, and there should be continuous operation, that is availability, location independence, fragmentation independence, replication independence, and it should support DQP, distributed query processing, and also it should support distributed transaction processing. And there should be hardware independence, operating system independence, network independence, and finally database independence. So these are some of the ideal things that can be supported in a DDBMS according to CJ date. All right. So we have seen a quick overview of distributed databases, DDBMS, and its architecture, and the importance of fragmentation, the different rules, a comparison between the replication options, etc. All right. So the next topic that we are going to discuss is actually on concurrency control protocol. So distributed concurrency control protocol. So we'll have a quick overview of that in the next class. So you have distributed access, distributed database plus concurrent access. So you have distributed concurrent access for the databases. So we will see that in the next class. Any questions on that? Any questions before we close?
So what is local mapping transparency?
Where?
Sir, in distributed transactions, sir, in distribution transparency, there was local mapping transparency.
Local map, let me see that. Where it was there?
In
where it
28th
came?
slide.
Slide number 28. And V27. Yeah, 27. Okay, ADB. Location transparency you're talking about? What?
Sir,
what
local
is
mapping.
the
Local mapping transparency.
local mapping transparency? It is not there.
Mm,
It is not there on the slides. Local mapping transparency. It is
yes.
not there on slide number 28 or 27. I mean, was it there on the slide, or
Yes,
you are
sir.
just asking what text?
Sir,
what
it was
is
there.
I will share again.
Yes, sir, it is there on the slide, sir.
Slide number?
Sir, 27, sir. Point
Let me
number
check.
2, sir. Otherwise calling local mapping transparency, it is written.
Slide
Other
number
name of it. In location transparency.
Slide number 27. Yeah, local mapping. Okay, location transparency, location of data items, otherwise called this local. Yeah. So when you are trying to access the data, the user should not know in which location that particular data item is stored.
Mm.
Maybe, I mean, you are trying to book for a ticket and actually the data is stored in Bangalore. That the booking program or the user may not be knowing how the data is mapped locally
Yes,
to
sir.
which local disk that is hidden from the user. Location of data items are hidden to the user. I need not bother where exactly the data is stored. All right. Maybe there are 5 copies of the data. It is mapped into 5 different locations, which I need not know as a user. Okay, is it clear?
Okay, sir. Yes, sir.
Mapping of the data into locations that should be or that can be hidden from the end users.
Okay, sir.
Yeah, any other questions? So as I said, I expect you to work out problems on normalization, also on join operators, on relational algebra, and also I expect you to know about the working of semi-join, queries involving semi-join and semi-join programs. Semi-join program means a query where you have multiple semi-joins occurring. All right. So A join, B join, C is actually a join program. Or I have A join, B join, C join, D join, E. It is also a semi-join program. I mean, it is also a join program. So when you introduce semi-join there, you can have multiple ways of taking that particular join sequence. So they are actually called semi-join programs. So please read about those things also. And then also read about fragmentation and the comparison of different options of replication and the 5 different parameters on which you compare the different options like selective replication, no replication, etc. to full replication. And I hope the project is progressing well and you are interacting with the mentors regularly. So our first deadline comes on 7th. So submit the reports on 7th positively, and then there will be some evaluations. So as I said, take the projects very seriously, and I expect all of you to work hard, and the evaluations are going to be on individual basis. So don't think that my partner is working, so I can relax. So each one of you will be evaluated on an individual basis. All right. Thank you. Thank you all. See you on Tuesday. Yeah.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir,
Yes, sir.
hello, sir.